Hey, and welcome to the Explainer. Today, we're cracking open the digital toolbox that every single Python programmer needs to master. I'm talking about data types. Think of these as the absolute essential building blocks you're going to use to construct, well, just about anything. So let's get right into it.
So, let's kick things off with a little puzzle. You know that 2 plus 2 equals 4, right? A computer gets that, no problem. But why does it totally freak out when you ask it to add apple and banana? It seems so simple, but the answer to this question is actually the key to understanding how programming languages think. And that right there gets to the heart of it all, the rules of data. Because in the world of programming, just like in the real world, you can't do the same things with every object. You can't add a piece of fruit to a number, and Python needs a way to know the difference.
And this is the solution. A data type is basically a label, a category that tells Python, hey, this is what kind of information you're looking at. Is it a number? Is it some text? That label sets the rules for what you can and, just as importantly, what you can't do with that piece of data. So it's not just about what the value is, it's about what it can do.
And here's a little pro tip for you. You never have to guess. If you're ever scratching your head wondering what kind of data you're dealing with, you can just ask Python directly. Just use the built-in type function. It's a lifesaver when you're trying to figure out why your code is breaking.
All right, let's start stocking our toolbox with the essentials. These are the basic building blocks, the fundamental tools you're going to be reaching for over and over and over again. First up, we've got the string, or str for short. The rule here is super simple. If it's text, it's a string. Names, sentences, paragraphs, you name it. Anything you wrap inside of quotes becomes a string. It's your go-to tool for handling any kind of text.
Next up, the numbers. Now, Python's got a few specialized tools for these. You have int for integers, your classic whole numbers for counting stuff. Then there's float, which handles floating point numbers, basically anything with a decimal point, perfect for precise measurements. And then there's complex, which is a bit more specialized for certain engineering and scientific calculations.
Okay, now for what might be one of the simplest, but also one of the most powerful tools in the entire box, the Boolean, or bool. It can only ever have two values, true or false. That's it. Think of it like a light switch. It's either on or it's off, yes or no. And that tiny little switch, it is the foundation for literally all decision-making and logic in your programs.
Okay, so we've got tools for handling one piece of data at a time. But what happens when you've got a whole bunch of stuff you need to deal with at once? Well, for that, we need our collection tools, containers that help us organize all that information. And check this out. This is basically your cheat sheet for collections. Seriously, this table is your new best friend. It breaks down the 4 main types based on 2 really important questions. Can you change what's inside it? And does the order of the items matter? Let's use this as our guide as we look at each one. We'll start with a list, which is probably the most common and flexible container you'll use. The best way to think about it? It's your shopping list. The order of items matters, and you can add things, cross them off, or change them around whenever you want. It's your go-to for a general-purpose, changeable group of items. Next up is the tuple. Now you might look at it and go, wait, that looks exactly like a list, but there's one huge difference. It's unchangeable, or what we call immutable. Once you create a tuple, you cannot alter it. It's locked in. This makes it perfect for data that you want to protect and make sure never, ever changes, like a set of coordinates. Then we have the dictionary, or dict. With a dictionary, we're not thinking about order anymore. We're thinking about connections. It stores data in these key value pairs. The perfect analogy is an address book or your phone's contacts. You don't find a person by their position in the book. You look them up by their name, the key, to find their information, the value.
And finally, we have the set. A set is super straightforward. It has just 2 rules. The order of items does not matter at all, and every single item inside must be unique. It automatically gets rid of any duplicates for you. So, whenever you just need to know, is this thing in my collection, and you don't want any repeats, a set is what you grab.
All right, so those are the everyday tools, your hammer, your screwdriver, your wrench. Now, very quickly, let's just peek at a few of the more specialist tools you might need for some very specific jobs. And these are the binary types. Deep down, your computer doesn't really see text or numbers. It just sees ones and zeros, raw binary data. When you need to work directly with that stuff, like files, images, or network data, these are the tools you'll use to handle that fundamental, low-level information. Okay, let's take a step back and look at the big picture here. We've gone through a bunch of different tools, but they all serve one critical purpose: to give our data structure and meaning. And that right there forms the foundation of everything we build with code. So, What's with the number 7? What does that even mean? Well, it's the whole picture. All those different tools we just discussed, from strings and numbers to lists and sets, they all fit neatly into just 7 core categories. It can feel like there's this huge complex world of data out there, but Python boils it all down for us into this really manageable, organized system.
And look, if you take away just one thing from all of this, let it be this. Understanding these data types is not just some boring academic exercise. Knowing which tool to use for which job is the difference between writing code that's clunky and inefficient and code that's elegant and powerful. Getting this right, it really truly is the foundation of all good coding.
So there you have it. We've laid out the entire digital toolbox, from the basic hammer and screwdriver to the specialized power tools. All the components are right here in front of you. So the question isn't, what are the tools anymore? The real question is, what are you going to build first?